Oh yeah, I was doing good this summer.
Except for they've redacted that. This one is now a miasma of plasma.
Ever.
True story.
I
I know, that's a way less interesting song now.
Because my teacher's pet, I've said. No, because I need that one.
I just wanted to come in.
Oh, yeah. We're struggling with that.
So the password for go to meeting is Castle Academy.
No, it's just dispatch, all lowercase.
Dispatch.
Yeah. Yeah, dispatch, all lowercase. Should be it. So, how's everything working with you guys as far as like the Google Drive and stuff? Good? It's okay?
Could you possibly, like, in the days that you put on the Google Drive, your video that we're supposed to watch first, that you get a link to the email, could you put that in the drive too? So
Like
it's
just
not
the link?
looking in two places.
Yeah, that would be.
Yeah, I can do that. In fact, I
On emails.
thought I did that, but
You did it on the first
On the
day.
first day.
okay, yeah, okay. Yeah, good reminder, yeah. I put it in there because I wanted to make sure you saw that one first.
Yeah.
But I guess I have been forgetting to put them on the actual page that has the other links. So you just want it like on the top of above those. Okay, I'll do that.
We'll just know to watch your videos first too.
Okay.
Just as far as, like, ease of finding them, not have to go so straight.
Okay. The one, I think most of them, except that one that was, the way that the class worked last time was it was Thursday nights and then Saturday mornings. And so that the ones that were in class ended up being like kind of different days than you guys see. So that's why that video was like, it was from the last class. So I think that would have been the only one though that I recorded that was not from this week that I actually recorded this week. So, but other than that, everything working good though. As far as the other question I had is, do you guys prefer this stuff like electronically like this?
Yes.
Or would you prefer like a big book?
No.
Electronic is okay. There are going to be some stuff that I do print out probably later on though that's like more for the flight planning, the charts and the flight plan packets, obviously things you'll want printed to be able to sift through a little easier than having to go back and forth into different folders to find stuff. But as far as like the initial stuff, I just want to make sure that this works good for everybody. Try and print as little as possible. But if there's anything you guys want, I mean, feel free to print any of it too, if you guys want to. Obviously, you can print it as well. So, is everybody kind of up to speed as far as the days go? I mean, not that you have to be necessarily, but just kind of trying to, I guess, figure out the pace more or less that you guys are.
I'm 1 day behind. Yeah, I'm behind.
Me too.
Yeah, I think I forgot to watch I didn't know there was a video in this email for day 4, so.
Oh, okay.
So I'll have to watch that later.
Okay. Those are all pretty short.
Oh, is it?
Yeah.
Okay.
The yesterday stuff, I don't think there's anything that was more than like 10 or 15 minutes max.
I think you're just talking about your video from your last class.
Okay. Okay.
That one's very long.
Yeah.
That one's like 3 hours.
Oh, is it?
Yeah. Well, yeah, and that's why that one was kind of crappy too, because it was one of the first times that we had been recording, and so you get a lot of stuff like this, like what we're doing right now, you know. So like this right now is being recorded. So, but then like the breaks and stuff, like see, there's this button right here that I can hit stop recording. You can all see it up there. But anyway, I always thought that if I hit that, it was going to shut the whole thing down, you know. So then I was going to have to like start over, and it'd be a whole different thing. But I can actually hit that button, and it'll just stop and restart, and it'll stay on the same video. So anyway, I wasn't doing that during breaks and stuff. And anyway, so I would imagine it was probably pretty annoying to watch. So, how about as far as like the understanding of all of the stuff so far? I know it's a lot of information kind of just being chucked at you. Yeah.
it's nice when you tell us, we were talking about that out front of the door, that you kind of give us an idea of what to focus on, because there's so much information.
There is.
I know I'm beating this to death. I know I'm not going to
Yeah.
memorize all this stuff.
Yeah.
So having that focus really helps, because there's a lot of information in there.
Yeah, there is. Yeah, and I do try and do that as best as I can before, like in the videos. And so, and if you feel like some of them don't do that, or if there's, maybe something that I forget, like, feel free to just, shoot me a message just saying, hey, can you explain a little bit better exactly kind of what you're looking for from this? Now that's kind of the thing. There is a ton of information, but in reality, there's, maybe this much of it, that ultimately is going to be like on a quiz. Like I tried to go through yesterday, on that video yesterday, and tried to kind of recap the days a little bit. I'm not sure who's seen that one, but as far as what I kind of wanted you guys to take away more or less from each day so far.
That was really nice.
So,
Being able to write them all down in order.
okay. And I'll try to do that as much as I can as well. So, let me just take a look here. So and I can look at them again. So yeah, so like obviously day one was, the first day in here, when we were just mostly doing intro stuff. Really the only thing in that, like, I think that I said in the video yesterday too, was just to know like some of those basic like FARs. Like we covered a few just small FARs, like being 23 years old or older to get your certificate, being, the 200 hours. That's really probably it as far as FARs on day one. That's really the only thing pertinent that we really talked about, other than watching those videos and stuff. But day two, yeah, the big thing for day two, obviously that's the first day of the weather stuff, it's really just having the basic understanding of how weather is created. It's not so much like, obviously this does, that's kind of the balance here that is a little bit of the problem sometimes with a class like this. There's FAA required stuff that we have to go over, but I try and sift down as much as I can. Like there's stuff that we just have to go over just to say that we covered it because it's an FAR for the class, right? In order to cover it and being able to check the box, even though it's not necessarily stuff that you need to remember and like that you're even going to use. So I really, during the entire course, I try to divide out the stuff that you need to absolutely know, like to be a dispatcher really in general, practically speaking. And then obviously the stuff that I, feel like you would maybe see on a practical test and things like that. With regards to like the ADX test, there's really not much. There are a few things in here you'll see that we'll cover that you'll see on the ADX, but most of the stuff, obviously you've already passed it. Most of the stuff that you saw and that you memorized, you're not going to see. And even if, depending on the manner in which you guys are even studying for it, if you're doing the memorization thing for the Shepherd Air, hopefully you're not really having to, really see it anyway, if that makes sense, other than just memorizing the questions. You might see something that looks familiar at some point in the class, but generally speaking, most of the stuff on the ADX, you won't hear a word about in this class. And that's the reason, because is almost all of it has nothing to do with modern day dispatch. So anyway, we live in that archaic FAA world. So anyway, aside from that though, the actual class stuff and the stuff that we are looking at in here, I try to narrow it down to the stuff that is really going to help you be a dispatcher and test on that kind of stuff. And then also, like, especially with regards to the weather, like looking at this as an example, like knowing regional weather types, maritime, continental, polar, tropical. The honest truth about like any of that stuff is, once you get done with this class, first of all, you're not going to see any quiz questions on any of that stuff. But even outside of that, none of that necessarily is going to help you dispatch. I mean, it might if you like start dispatching like kind of in weird places, that you have no understanding of weather for. But generally speaking, when you learn how to dispatch, or if you go to an airline and you start dispatching for them, you learn a lot about their weather type for the cities that they fly in and out of in their classes. So if there's anything specific that's not routine or not normal, then you'll normally learn about it specifically. Like SkyWest as an example, we fly to a couple cities up in Alaska, and we all kind of had to learn a little bit about the weather for those cities because it's a little bit different than this, the stuff here in the lower 48. Also, we at times have flown into like the Bahamas and places like that, like down kind of in the Caribbean, and same deal. We had to kind of learn a little bit, when we launched those cities, we had to learn a little bit. But there was like information sent out before anybody had to dispatch to those cities so that they could, do a little, we call them like little briefing guides that we do. There's other cities like some of the mountain ski resort cities, Aspen, Eagle, Sun Valley, places like that we fly to that are specific and have some specific weather criteria and kind of local weather conditions that occur there that, you don't see. And it's because they're high elevation up in the mountains, stuff like that. But you learn about those individually and specifically before you ever dispatch. So the reality of weather is most of it everywhere we fly is going to be the same. Now you'll start to recognize, different cities. Like for instance, when you start looking at coastal, mountainous, island, plains, like coastal is an example. Obviously, we fly to a lot of coastal cities up and down the West Coast and now even the East Coast, but primarily the West Coast from Seattle all the way down to San Diego we fly to, and about 50 cities in between there as well. So lots of little cities, San Luis Obispo, Santa Maria, Santa Barbara, Monterey, Arcata, Eureka, all sorts of cities up and down the coast. And you'll start to learn that coastal cities have certain patterns that they follow as far as fog and cloud ceilings and things like that. It's important to kind of learn about what the characteristics of a city that would be considered coastal is. But outside of that, I mean, you're learning primarily about like a regional, weather type, or, a city that, a coastal city, you start to learn about, the wind is always usually one specific direction. When it's the morning time, you get a lot of fog, or when it's night or sunset, you also get fog. So you start to learn about little things like that. But outside of, just those types of specific things, most weather generally where you dispatch is going to be kind of the same, not the same, but the same types of weather. You'll see, like, you'll understand, how it works, whether they're getting a storm or whether it's a nice clear day. So the other thing on day 2, just the atmosphere characteristics, really the most you need to really understand there is just that, we fly in the troposphere basically, and then just what it's made up out of. Those are the only real questions you ever hear about the atmosphere. It's the only time you'll probably ever even talk about the atmosphere will be in this class or like in a practical test for this class. So nobody in dispatch is ever sitting around talking about what the atmosphere is made up out of. So anyway, so let's see. Yeah, so that, yeah, and this stuff I think I went over, just this one, for day 3, just knowing your cloud types. And we're going to look at a little bit more of that today as well, but cloud types, then from yesterday, fog, types of fog, icing, or ice, I should say. What's that? So yeah, and just understanding how like the convective process works. Does everyone, I know some of you probably haven't seen the day 4 stuff yet, but just generally speaking, do you guys know how like a thunderstorm is created? Has anyone ever learned, like, in any type of class? What's kind of your understanding of how?
So you've got the lift component of it starts low. Once it gets pushed up high, the air gets colder. Hot air can hold more water than cold air. So once it gets colder, the humidity rises till you eventually reach a dew point where you can't actually carry all the water, at which point it starts to condense and start forming individual water droplets. Water droplets touching more and more water to start building. And then eventually the lift can't support the large water droplets and it just dumps.
Yeah. And then what causes the convective component of it, like the electricity component?
Friction.
Yeah, friction, everything kind of colliding together. It's also kind of like when he's saying, so like when a cloud is forming, and this is kind of what the overall principle of this from yesterday, the stability, instability, temperature, lapse rate, convection, the adiabatic process, lifting process, this is all kind of how weather, but even specifically when you look at it like thunderstorms, how it's all created. But yeah, it gets to the point, it evaporates. It's kind of like when you're talking about your scientific things, like when things turn from liquid to gas to solid. So first, you're starting out, the ground is being heated up, and you have to have a moisture component in there, so you have to have something evaporating. Because if you look at like St. George as an example, what do you guys think is the difference between, say, like, why do you think we get thunderstorms like really starting in like August? Like, why don't we get them in? Obviously, it's hot here in June and July and May, but we don't normally see thunderstorms. Does anybody have any guess as to why? Yeah, but what? Even looking at it even furthermore, like, what is it that you think causes the air to be drier here earlier, but now like this time of year it's more moist? Any idea?
Mexico, doesn't it?
Yeah, it comes from Mexico. And it all kind of, the whole idea though, it all stems back to the whole uneven heating of the earth by the sun. So if you think about like the way that the sun, seasonally speaking, how the sun is coming up, from the equator. So, like when we're coming out of winter as an example, the sun is in wintertime obviously down, primarily the equator and below, due to the tilt. But once we start getting into summer, the sun obviously starts coming up. It starts warming up that area, all south of us in Mexico, out on the Pacific waters. And then it goes obviously to where we're in the middle of summer to now where it's extending up higher. But as it comes north and as we come into summer,
Speaking of storms.
yeah,
They just came on and stuck the filter up into the thing. They changed the filters.
yeah. But as the sun starts moving north, it heats up all of the northern hemisphere, but it doesn't. It's kind of an interesting way it works because as it moves north, like at the beginning of summer, and it's coming up from the south, and how the angle of the sun, how in the winter you see it more low, but as the summer, you end up seeing it straight overhead and then setting off in this direction, as it reaches kind of that point, where you hit the summer solstice and the sun starts now working its way back. It's more of all of that time, like from winter to the summer solstice. Although it heated up the earth and everything coming as it moved that direction all the way through the end of June, once it hits that June 21st date and then starts moving back, as it comes back is actually what causes like those monsoonal type patterns, like off the Gulf, out in the Pacific. That's actually, it's when the sun's coming this way, it doesn't heat up enough as it comes up to June, and into the middle of June or whenever, I guess June 21st, as it's coming up this way, it doesn't heat the earth and the water enough to actually create like those situations. Like when the water heats up enough, that's what's going to cause your wind shift and the evaporation off of the coast of California. That's ultimately what causes the monsoons to come this way. But it's really from June 21st on, as it starts moving its way back, and then is back kind of centered over our area, and as it moves back down over Mexico, going back towards the equator, just heading that direction because it was already heated up and now it's getting heated again. That's actually what brings it to the point of creating the mass evaporation, and then having those air masses move over, Southern California up into Arizona, Southern Utah, because you don't see that like in Northern Utah. Anybody that's from up there, it's really just a Southwest desert type monsoonal thing. So anyway, it's just it's cool to kind of, for me, that's the part of weather that I like. I like being able to understand, well, why does it do that? Why is it that time of year? Like, my wife and I always have discussions. My wife is from the South, from like Arkansas, Missouri area. And she's always talking about humidity and things like that. And anyway, we always talk about how like our favorite time of year here in St. George is like from like August on because of the rain. Yeah.
So I used to live down in Lake Havasu City, Arizona, and we had an insane monsoon season.
Yeah.
But they were always, like our storms were always in the evening and through the night.
Yeah.
Is there a reason why?
Yeah. It's primarily that has more to do with just the local spot of where it's at, because what happens in those situations is like during the entire day, you've got a heating process that's going on all day. And it's kind of in a way, like if you remember like a few nights ago, there was a pretty good thunderstorm that rolled through here in the middle of the night.
Yeah.
And that's probably more what you're used to, right? Yeah. And the reason for that is really just because it heated up all day long. And even though the sun goes down, that heating, as the earth starts to cool, especially like at night, once the sun goes down, you get all of that heat that has just gone up all day long. And then finally, as the sun goes down, it's kind of going back to like what John was saying, depending on where the cooling factor is, like where the air is located. Like for instance, you can have heat all day long, and if there's not enough evaporation going on for it to keep lifting and lifting and lifting, eventually it's going to lift. If there's enough of a lifting process going on, it's going to lift all the way until it gets so high in altitude that it cools. That's where you'll see a thunderstorm like in the middle of the day. But in the situations where it happens late evening or even at night, it's simply because there wasn't enough of a lifting action during the day to keep it. Like it went up to a certain point, but it never got to the point where it cooled enough to actually return and condense back to water and actually form a storm. So once the sun goes down, if you can think that cooling spot in the atmosphere slowly lowers because the temperature slowly lowers. And so that you still have that mass of water vapor that's in the air, but now the actual cooling point has now come down and reached that spot and causing it at night. So that's simply the only difference. It's just that there's not enough water vapor to have it happen during the day because it's too hot to get high enough. So it really just depends on how the ultimate equation for that is just how much water vapor there is in the air and how much evaporation, how much lifting is going on. And that's just going to depend specifically on, the time of day, the air mass that's over your region at the time. When we get those like the monsoons like during the day, it's because the air has so much humidity in it that it's already got all of the elements needed to form and just go way high. As far as the cloud tops, you'll see them as high as 70, 80,000 feet. And so anyway, that's the primary difference between those types of storms, where you see them during the day, during at night. So there's also a lot of different types of storms that you don't see. Is anybody from like more of the Midwest or out east at all? Like out there, you see like big lines of thunderstorms, like where, because there's no mountains, you get a huge line of thunderstorms that extends from, Chicago, and you'll see it go all the way down into Texas. But it's like a solid line. Here in the mountainous area, you never see that. You just see a thunderstorm cell pop up over here, one over here, but they're not connected. Like they're just individual. They're called air mass storms. But when you have like a cold front that moves across the plains, it forms, as it pushes that cool air, it forms a huge line all along the entire cold front. And it literally, if it's bad enough, planes they can't go through it. They have to like fly all the way down into Texas and go like underneath it and then go up, or over around the top. So just depending on, and you'll see it. It's really cool to see. It sucks for dispatching, but it causes a lot of traffic problems as far as airplanes are concerned. But it's kind of a cool thing to see and understand why it happens. But really the coolest part about weather, if you're interested in weather, is just understanding how it forms and being able to see something happening or be able to predict something happening before it happens is kind of cool. Like if you're dispatching and you start looking at an area and you're thinking, that area, just because of like the humidity level, the dew point, the temperature, and then you start looking at like the way that the wind's blowing up. Like in the Midwest, you get a lot of that warm, moist air that moves up from the Gulf of Mexico, and then it meets up with the cold air coming down from Canada, and they like converge right over the Midwest. And that's, where you get that tornado alley zone. That's exactly what causes that area to be called Tornado Alley, is just because it's the warm, moist air from the Gulf meeting the polar air from Canada. And that's about where it meets, and that's where it hits. And that whole line in that area just gets tons of tornadoes because it's a convergent zone right there.
If you were dispatching, you're looking at that flat what you're talking about, what would the criteria, just something quick, I don't jump ahead, but what would the criteria be to go like, hey, you have to fly to Texas at 700 miles to your trip?
The biggest criteria is just going to be like when you're looking at the storm front, like if you're looking at a line of thunderstorms, like for instance, the other day as an example, I had a flight, I was dispatching, I had a flight from Denver to Nashville. So you can think the ideal thing is obviously to fly as straight of a route as you can, but there was a big line of thunderstorms that was really on the North Texas border, kind of around Amarillo, Texas. If anybody knows where that is, that's kind of where it started, and then it extended all the way up into, it was close to like Des Moines, Iowa. That's how long it was, and it was a solid line. And so the captain called me on the phone, and we were talking about it ahead of time, and we were trying to figure out. And so, like, the way that you can tell, like, as a dispatcher, though, is you can bring up a little tool that shows all of the flights up in the air. And you can just see that the best thing to look at is just to look at what ATC is actually doing with them. Sometimes you'll see it where they're taking them through a part of it, and then it's kind of hard to distinguish, like when you're looking at it like on a radar screen, to how bad it is or if there's an actual gap. There's always going to be a little bit of a delay at the radar that you're looking at as compared to like ATC radar that's real time. So a lot of times they can see little gaps, that might be 5-6 miles wide that they can send planes through. But how quickly that gap opens and closes can be a whole different issue though. So, but you start bringing up the traffic patterns and you can actually see, where they're swooping down or going above, or if there's a little spot that they're going through. That's the primary thing that dispatchers will look at, is just what the current traffic is doing. And then even if the traffic is being taken through somewhere in the middle, you can't necessarily bank on that same spot being open, at the time that your guy's going to go, because you're talking about maybe 2-3 hours into the future at that point. So usually the safest thing is always just to plan as if he's going to have to go around it. And then if ATC ends up giving him a shortcut, then you just end up with having more fuel,
ATC is just traffic control.
Yeah. So that's what you normally do. I mean, a lot of it's just going to depend on the comfort level of the pilot, because even if people are going through an area, the pilot might not feel safe. So he might, I just want to go underneath it. Some are a little bit more, some are cowboys and some are not. So
there was one in Chicago was going down. You could see it just getting hammered. Everybody was diverting left and right. And
yeah.
you see this one plane just 435 area code. No problem.
Yeah, that's the thing too. It's the thing is you're going to end up dealing with a lot of different personalities, and the thing is when you think about just dispatch in general, your problem, I mean, you're going to deal with problems every single day. I mean, if you have 50 flights on your desk that you dispatch, you're going to have problems with some of them. Some of them are going to go off without a hitch. Most of your flights are not going to give you a problem. The majority of your workload is the 5%ers, basically, or and whether that be the 5%er captains or the 5%er just flights, just geographically where they are that day, they're in a problem weather area, So that the majority of your work is always going to be your problem crews or your problem flights due to weather or maintenance for that matter. But the thing is what you get used to in dispatch is you get used to the fact that you're going to have problems every single day. And so you start seeing all of the different types of problems that you can deal with. As you dispatch for a year, 2 years, 3 years, you start to develop this experience bank of having dealt with this problem, that problem, this problem. And the thing about it that you have to remember is that a lot of crews don't see, first of all, nobody in the airline is going to see the problems to the extent that like a dispatcher sees them, because we see them every single day and we deal with them every single day. And so you're going to end up dealing with people that don't have any experience dealing with that specific problem, but yet you are very experienced dealing with the problem, so you know exactly what to do, and you're going to find that you're going to have a lot of those people kind of disagree with the way you want to approach it, from a safety standpoint. So you find that you'll end up doing a lot of kind of like talking into, a lot of hand holding, just trying to say, no, I see this every day. If you just do this, this, and this, you'll be fine. And, worst case, if you can't get in, you divert. But sometimes it takes a lot of convincing, to convince a crew to go and do some of your crazy ideas. But it's just usually simply because they don't see it. I mean, from a dispatcher standpoint, you'll have several flights, just in a given week, in a 40-hour week, you'll have several flights of yours divert for whatever reason, mechanically, due to weather, any medical emergencies. You'll have a lot of different scenarios. And then you'll talk to a crew. I had a crew a few months ago that came in just doing a tour of the OCC, and I've kind of gotten into this pattern because it just totally amazes me how crazy this is. But I started asking any crew that comes into the OCC on a tour how many times they've diverted. Okay, just them in their own careers. There was a guy a few months ago came in. He's actually retiring at the end of this year, but he's been with SkyWest for 35 years. So you can only imagine how many flights this guy's done. He has never diverted, ever, not one time. So, and the thing is about it is, when I first heard that, I was thinking, because he was one of the first ones. The reason I even started asking people is because this guy, he actually just brought it up and he said, you know what, I've never diverted. Can you believe that? I'm like, you got to freaking be lying to me, because that just did not sound believable at all, especially from the standpoint of a dispatcher. You see how many diversions the company gets just in one day and how many you have to deal with personally, and you start to think like that's impossible, but it just seems impossible because you are dealing with those 5%ers every single day. And so, they don't fly 50 flights a day, but you technically deal with 50 flights a day, whether they go off well or if they don't go off good, just regardless. But I started to kind of think of the math behind it. I'm like, well, let's see, on average, SkyWest, maybe 1 to 2% of our flights divert every day. But in fact, probably not even that. I mean, we fly 2,400 flights right now a day. So we might have, if we had 10 diversions in one day, that would be considered a lot. So, I mean, the percent, it's not even 1%, right? So if you think about it, I mean, every crew really starts off the day with less than a 1% chance of diverting. So going 35 years without ever hitting in that 1%, actually, when you look at it that way, seems pretty reasonable. And and since then, I've started asking every crew that comes in, hey, how many times have you diverted? Some. Now I've had several people that have said none, but most people are like less than 5 or 2, 3 in their entire career. So when you deal with diversions and problems like this, it doesn't matter if you're dealing with somebody that's brand new or somebody that's 35 years in. The experience level is just simply not going to match that of the dispatcher. So you're really expected to make the decisions. Most of these decisions and most of, when it comes to diverting or making emergency decisions, you're going to find that the dispatcher is the one who actually makes the majority of those decisions. And it's just simply because they are not used to dealing with it at all. You are. So if a plane is going to divert, typically you'll get an ACARS message. And ACARS is, for those of you that don't know, it's like a text messaging system from the cockpit to the dispatcher's computer. They can just send a message. But you're just going to get a message that just says, where do you want us to go? And you basically, okay, you start looking around. Okay, I wanted to go here. So, yeah, those decisions are almost always made by the dispatcher. So a lot of people think that the dispatcher doesn't have a lot of say, a lot of input, and for the most part, you don't. The dispatcher really is involved, like I said, on those 5% of flights, because most flights take off and land without you even talking to the crew. So it's just the ones that have problems. So you really get into the pattern of just dealing with problems. It's the same with crew support, right? You guys really just deal with the 5%ers. And we start to think that the 5%ers are 99% of the people because that's all we deal with. And so we think that all the crews, are lazy and want to call off. But you start to realize, 99% of them you don't ever hear from. But you hear from the same ones, though, over and over.
There's a big long list of topics.
There is a big long list, yeah.
So what's considered a diversion, just barely going off your route?
No, a diversion is landing somewhere that you weren't supposed to.
Also, they actually have to land somewhere else?
Yeah.
Oh, that's crazy.
Yeah, now deviating is probably more what you're talking about. Like if they deviate from their route all the time, probably almost every flight.
Yeah.
You'll plan a flight, you'll plan a route, and it's very rare that any of your flights fly the exact route. I mean, usually it's because they get a shortcut and it ends up being shorter. Like you had them going here, and then ATC will just take them to here and then go straight to there, or whatever.
So we don't really have anything to do with their deviating.
No, it's mostly ATC.
So
Yeah.
we're just doing like a general path, and they can.
Yeah, well, you have prescribed routes that we file. Like if there's nothing going on with if you have a flight that goes, like going back to the Denver-Nashville one that I did the other day. Generally speaking, if you don't have any weather in between Denver and Nashville, then there's a route that's already pre-built that you don't even have to do anything with. That just is the best available option as long as there's nothing going on. And that's the route like we're always like thinking that we want to do. Like at the beginning of every flight, you want to file what's called the canned route. And the canned route on any flight is just going to be the route that the company has made up that it's the best possible route without anything affecting it. And so that's what you're always shooting for. But the only thing that's ever going to push you off of the canned route is going to be something like weather or like a mechanical issue with the plane that it can't go a certain direction or it can't climb as high or whatever. So, but actually when they fly the canned routes, ATC a lot of times gives them little shortcuts, here and there. I mean, generally speaking, they're flying that route, but, not usually the entire thing. So, but yeah, diversion is is landing at a destination that was not your intended destination. That's kind of the definition of it. So
See how that you can follow.
yeah.
Have
What
a
happens?
snowball all day.
Yeah.
Throw out all the flights all day.
Yeah, well, and one little thing too, I was working the Denver regional controller desk the other day, and we just had one little, it's all about timing, If all of these big airports are timed, they align themselves in what are called banked hubs, and, for parts of the day, they have a huge, big bank of inbound flights, and then those flights come in, unload, load back up, and then you have a huge bank of departures. But then there's a little lull of 2 or 3 hours where there's nobody at the airport, in the huge airports. And about 2 or 3 hours later, you start getting those planes that left a few hours ago. Now they're coming back again, but they all come in and out at the same time. But that's obviously it's timed that way for connections, and stuff. But if you have like a thunderstorm pop up over Denver at the wrong time, right during one of those inbound banks, you will see 50 plus diversions, usually at least.
Wow.
The other day when I was working the Denver desk, and not that they're all SkyWest, but we had several flights out there, but you got United Mainline, you got Frontier, you got Southwest, you got us going in there all at the same time. And they, I think that there was like 70 something diversions in the matter of like 30 minutes or so.
So we know when other airlines are going.
Yeah, like on that. If you've sat with have you ever sat with anybody up in dispatch?
I haven't.
Well, when you do, you'll notice they have a big map screen that just kind of shows all other planes. But if generally speaking, it's only showing SkyWest planes, unless we have it programmed to where if another airline files a diversion, it'll pop up on our screen. So all of a sudden you start seeing all these little things light up of all these planes, and it shows them all diverting, and they're all encircled around Denver. You see them. Okay, one's going to Colorado Springs, one's going to Pueblo, one's going to Laramie, Cheyenne. You start seeing them. It says where they're going, and then they just start popping up, and then you see the SkyWest ones are red, so you'll start seeing the SkyWest ones. But anyway, I was working our Denver desk. I think I had 7 or 8 that were actually SkyWest ones. But in total, for all airlines, there was like 70 something. So it can get pretty crazy pretty fast. So anyway, yeah. So yeah, okay. Then learning about turbulence. Just so all of those things there. Just know the different types of clouds. Fog types, ice types, and then how the turbulence is associated. And remember all of this stuff too. I'm trying to keep it down just to the basics. You do want to know the basics of fog and ice and turbulence, but a lot of this stuff too, remember, it's going to come full circle back around once we start flight planning and stuff. So anyway, so any questions on anything that we've done so far?
If you have a cool icing video that you can, or something that just kind of shows where on the plane, because it explains what parts of a plane are affected, but for an untrained mind of knowing what those parts are on the plane. So if you just stumble upon something that kind of shows
I do have one. We actually will look at icing a little bit more in depth in a few weeks when we talk about aviation hazard, like weather hazards specifically. So there's a section in here for later on that is just strictly weather hazard, like weather hazard accidents even specifically. So we will take a look full blown at an accident that happened in Chicago, or a plane going to Chicago several years ago that was completely due to icing. And it goes through the whole thing and it'll show you. So you'll probably enjoy that. As far as, not enjoy people dying, but,
When you talk about de-icing on the aircraft, they must have heaters or something in the airfoils, I guess, forward part of the wings.
So what a lot of it is like the wing itself can flex and it shatters the ice off of it.
Oh, just naturally, it just fluctuates.
Yeah.
Oh, it has both of those. So prop planes are what he's talking about. Prop planes have what are called de-ice boots, and they hit a little button, and there's like on the front of the wing, it fills up with air, and it just kind of expands. Like you think it's got a big rubber like boot along the front, of the wing, the airfoil, and it just fills up with air and it just expands that ice, and you just see it all just shatter off. But that's only on prop planes. On jets, you get the heated. What it does is it just takes the bleed air from the engines and it routes it into this ducting along the fronts of the wings, and then also around the engine inlets, and then all up on the tail. If you look at the front leading edge of the tail, the wings, or the leading edge around like the intake of the engines, you'll see that there's a big silver lining around all of those. And there's ducting that goes around or along the front of the wing. And when they turn on the anti-ice, all it does is it redirects, like I think it's like 12 or 1300 degree air coming off of the engines, just right through those ducts, and it just melts all the ice right off of it. So that is how it works on a jet. But yeah, you'll see all of that stuff when we get into systems and stuff. It's pretty interesting how they keep planes in the air. So, okay, well, if you guys don't have any questions on anything we've already looked at, then let's dive head first into today's stuff. Let me get back to where I need to be here.
Have you ever been to Antarctica?
I haven't.
Because I want to go really bad after watching that video.
What? Has been impossible to see in the whole 500,000 miles of sword?
It looks so exciting.
I've been in the Arctic Circle once already. It's enough times for me.
Really? I consider I have to do it again.
In Cabo, on the beach.
I thought that I put in the order, but I guess I didn't.
It was that was interesting too. I loved that video so much. I wanted to watch it again.
The one, like the 2-hour one?
Yeah, it was so amazing.
Yeah.
Yeah, it's good as far as like learning about like how stuff clear across, like in a totally different area of the world can cause like a hurricane,
So
over here. Sorry, I
So easy to listen.
thought that I had loaded this file into the head.
She's like, all the videos should be so relaxing with this great English accent.
No, I wish I really liked this. Mine are a little orange. I just didn't cook last night. This is like the. No, they're just like the little or those one colors, so I can't get any sense if they are simple colors. Yeah, those are my favorite because they're so inexpensive and they go on so nice and they dry so quick.
Only 20 pages this time? Come on, you can do better than that.
I know. It's weak.
Got more pictures, please.
Give us crayons. Snack maybe. Nice.
I can't remember how to do the full screen view. Does anybody know how to do that? Full screen mode right there. Okay, so this is what we're looking at today. Air masses, fronts, and then the different types of storm systems. So the biggest thing today obviously is going to be the bottom one there, the storm system, the thunderstorms, tornadoes. That'll be kind of the the bigger part of what we look at. But the air mass stuff, you've kind of already seen a little bit with this, just kind of in the videos that you've seen, the different air mass, like the source regions, and what is basically causing, like the cooler, the polar air masses, the tropical air masses. There's not a ton of like information that you guys really need to know generally about air masses. I mean, it's pretty easy for you guys to obviously figure out that, you've got polar air and you've got tropic air, and why a polar air would be cooler. I mean, most of that stuff is pretty easy to reason. But we'll probably spend more time looking at the fronts and the theory of the storm systems. So let's start out just by, I'll put these videos on here. I'm not sure if it's going to go through to that very well or not.
Low pressure systems that move across the United States. And as these low pressure systems move across the United States, they have a counterclockwise circulation. So here we see the bubbles spinning around counterclockwise. As the low pressure comes here, you'll notice the air that moves up into New York State is coming from the south. So we have a large mass of air moving into our area. And that air mass, that large mass of air, is coming from the south, so it tends to have a little bit warmer characteristics. But as that low pressure system moves across our area, now look where the bubbles are coming from. Now the air that comes into our area is coming from the north, kind of from Canada, and now that air is generally cool. So the mass of air that comes into our area is a little bit cooler. And we can talk about air masses. We can talk about these large masses of air that move into our area. Here's a map that shows where these large air masses might be coming from. So if we look at this one air mass here, we notice that this air mass is moving into our area kind of from central Canada. So it's going to have the characteristics of that area. It's going to be a little bit cooler. Since it's over land, it's going to be somewhat dry. It's not going to be very moist. And compared to that, we have another air mass down here in the Caribbean Sea. If that air mass moves into our area, that air tends to be a little bit warmer. And since it's formed over the water, it's also going to be a lot more humid as well. In our area, we generally have about 5 air masses that move into our area. Those 5 air masses are the continental tropical, maritime polar, continental polar, and continental Arctic. So these 5, generally speaking, these 5 types of air masses, an air mass is just a large mass of air, move around, and these types come into our area. And what we do is we talk about their characteristics. So if I have an air mass that's continental tropical, being formed over a continent, and
I'm going to pause it for just 1 second. First of all, you don't necessarily need to write any of this down or know any of this stuff specifically, but just kind of going back to what we were just talking about before, what do you think? I mean, obviously it says Arizona, Mexico there, but this hopefully kind of helps make sense to kind of what I was saying earlier about the timing of the year of why we get the thunderstorms this time of the year. It's going back to that where if you see these air masses, we're getting one of these air masses right here that's coming down, coming up from Mexico and, down here in the Pacific where this water's been warmed up, and it's just moving up over our area. Earlier in the summer, during May, June, we still primarily have more of the pole, even though it's still really hot, the majority of the air is still this drier polar air that's over our area. And we don't normally get these warmer, moist, tropical air masses until once you get into mid to late July into August, September. So anyway, hopefully that kind of puts a little bit of that into perspective kind of from what we were talking about before.
So one question. So you're pointing out those air masses, and the top one, you said that one is more like a dry air. It's cooler but still dry.
Mm-hmm.
and the other one's more moist, but if they're both coming from over water, why is one dry and one is?
It's because of the temperature of the water. So of a cold, drier air mass, there's not going to be as much evaporation that goes into the air. So if you think about it just from the sun's element, like on those, anything that's closer to the equator is going to be more humid, right? Because just simply because of the temperature, the amount of sun that it gets, it's going to evaporate a lot more of the ocean water. Once it gets up really high up north, like, up into Canada, Alaska, although you do still get, even up there, you still do get a lot of rain, like even, along the inside passage of Alaska and all that, you still get a lot of rain and stuff up in that area, but the air masses that come from those areas moving down just because they're cold, it's just simply because there's not enough, it's because it's so cold, the water can't evaporate, so you never get a lot of water in the atmosphere. That's the only reason, though.
So that would be
Maritime tropical.
What's that?
That would be the lake effect there, because I always wondered about that. That lake's evaporating, you got that cold, dry air, and it's making it dump on the Wasatch.
Yeah, in fact, I believe there was something in the reading about the lake effect, right? Because it talks a lot about the Great Lakes, and then specifically talks about the Great Salt Lake. For Salt Lake City, you get the lake effect snow. But yep.
Maritime polar, continental polar, and continental Arctic. So these five, generally speaking, these five types of air masses, and an air mass is just a large mass of air, move around, and these types come into our area. And what we do is we talk about their characteristics. So if I have an air mass that's continental tropical, being formed over a continent, and it's tropical, it's generally a warmer air mass, we say that it's dry and hot. Maritime tropical tends to be humid and hot. Right, that makes sense. Maritime, you think marine, the ocean. Tropical, warm. So go ahead and get this copied into your notes. The nice thing is that some of this information about air masses can be found on page 13 of your reference tables. So if we turn to page 13 of the reference tables, one section talks about the air masses. It gives the symbol of the air masses, and it gives the name associated with that air mass. So if we look back at your notes, some of this information is already provided for you. The name of the air mass is given to you in the reference tables, and the symbol is given to you in the reference tables. So you don't have to memorize any of that. What you do need to know, though, is what are the characteristics for those different types of air masses.
Known as meteorologists, say air masses are distinguished by two major characteristics: their temperature and their moisture or humidity.
We've got air masses that start off, their name either starts with continental or maritime. If it starts off as continental, the type of air mass is a continental air mass, it means that that air mass formed over land, right? Continental continents formed over land. And if it formed over land, it tends to be dry. So whenever you see the sea to start off an air mass name, that tends to be dry air. Right? The opposite is true when we look at the term maritime, right? When we see the term maritime, we think of marine or marine animals. Maritime means that it formed over water, over an ocean or the Gulf of Mexico. And so whenever we see an M, we think of that as being very humid air. You might think M, moist, very humid air. So if you can remember the continental is land and maritime is water, then you're all set. The ending of the name is usually either a polar air mass, and of course polar means cold, or it's a tropical air mass. Tropical meaning warm or hot. And then there's also the one air mass that's Arctic as well. The continental Arctic ones are very cold, very, very cold air masses that come into our area. If we take a look at this map again, we can label where these are from. The first air mass that we talked about here coming from Canada, this air mass here would be a continental polar air mass, CP, because it's continental formed over land. Polar, it's from a colder area coming up to our area. If it's from further north, those are the continental Arctic air mass, very, very cold air in the dead of winter that come from the North Pole almost. The other polar air masses are maritime polar. If it comes from the northern Pacific and across the United States, or if it comes from the northern Atlantic, We call those maritime polar air masses. The ones from the south are tropical air masses, and if it comes from over water, we call those maritime tropical air masses. And if it comes from over the land, Arizona, Mexico area, we call those continental tropical air masses. So you know the name of the air mass, you know the symbol. We can get those from our Earth Science reference tables. Again, this is found in your reference tables on page 13 of your ESRTs, your Earth Science reference tables. The other thing that you need to understand is this term geographic source region. Right? Geographic source region is just a fancy way to say where something's from. Right? Geographic means the name. Right? Geographic is the name of a place. Source is where is it from? Where did it originate? And the region is just a place, an area, a location. So geographic source region is just a fancy way to say what the name of a place is, the name of the place where the air mass originated. So whenever you see geographic source region, this term is used quite often. You're thinking about the name of the place where the air mass originated, we have a low pressure system here, and we see that the air coming into the New York area is coming from the south, and I see some bubbles coming from the Caribbean and the Gulf of Mexico. We might say that there's a maritime tropical air mass moving into the area. And that tells us a lot about what's going on with the weather and what sort of weather we could be experiencing. Again, we generally get 5 different types of air masses. You need to know their characteristics as well as their possible geographic source regions.
So the big thing there with air masses, really, I mean, the only thing that I really care about you guys understanding with it, I'm actually going to bring up a weather thing here real quick. The only thing I really care about understanding is just where your air is coming from. That's pretty much all he's really talking about. It's just where is the air based on the fronts or whatever that's coming into our area or whatever area you're looking at, where that what the characteristics of the air is going to be. I'm going to bring up the map here really quick and just take a look at today's weather. I can type in my password correctly. It's National Aviation Day, huh?
Wow, we should be having a party.
I agree.
That's true.
Mexico?
You get all those on your seniority.
What's that?
Get all those on your flight bennies. Party in Salt Lake for a while.
Yeah.
I think the Courtney Shepherd benefits, but
She doesn't. Nobody.
herself.
I know. She tried one time.
Oh, yeah.
No, I
well,
didn't.
you thought about trying one time. You're gonna try
You
it.
thought about trying. You were gonna go to Florida. Yeah, we went to Hawaii.
Oh yeah.
Yeah, that was not happening.
Yeah.
But you were gonna try.
How long?
7 months?
How long did you work?
Is that showing up pretty good for everybody?
Yeah.
Yes.
Okay.
This weekend. You need to get better at that. Yeah, I'm gonna wait until I have
Okay, so just looking at this real quick. This is the current weather that's out there right now. This is just kind of a satellite image of what's going on. But kind of going back to that, when he had that screen up that had the rotation going on with it. So when we look at the difference, and we're going to look at, I know you've already seen some of like the pressure systems, like high pressure, low pressure systems. So does anybody remember what the characteristics of a high pressure system is? Well, I mean, it could have either technically, but really, I guess kind of what I'm looking for is like the rotation. Does anybody know what the rotation is? It goes clockwise, right? So if we have a high pressure system, let's just say centered here over Utah, you're going to have, actually I want that to be a different color, but let's see. Maybe I'll just do this. Anyway. It's going to be rotating.
That's why I thought the high pressure was colder.
I mean, generally they can be. I mean, high pressure can be cold or warm though, technically. So when you're looking at, there's a couple of different things you're looking at. You have warm fronts. So there's fronts, which we're going to look at today. Warm fronts, cold fronts. Those are kind of going to be more distinguishing with your temperature. But then high pressures and low pressures can be, generally speaking, they are more associated with warm, and low is more associated with cold, but it can be either one of those.
So maybe just in the one system that she was showing us, it was that way all the time. What was
Yeah, well that's a high pressure. So a high pressure system, when it comes in, high pressure, the basic thing that you want to remember about a high pressure system is just clockwise movement. And so that means that the air, if you're like looking at here, I mean your air is, circulating like this around a high pressure system. So the basic thing that helps you understand is if you see a high pressure system, and one of the other things I want to go into here in just a second, we'll bring up the pressure systems that are currently out there. But if we have a high pressure system sitting here like over St. George, this is an example, the area around St. George, like let's say it's literally sitting like where my red dot is, that means that the area, let me see if I can highlight this real quick. If it's centered right here, it basically means that the air around it is going to be circulating clockwise. So if you're over here in this part of Utah, that means that the air that's going to be coming towards you is going to be air that's being drawn from the northwest, right? And it can be different depending on the placement of the high pressure, because if you're down here in Palm Springs, let's say, the air that's going to be coming at you from over here is going to be coming from the Arizona, it's going to be coming from the northeast desert area. So, and then if you're up here in, say, Sacramento, Central California, San Francisco, the air is going to be coming straight up from the south. So that's going to depend a lot on what type of weather you're going to be getting. So the weather that you might be getting in San Francisco is going to be pretty different from the weather you might get if you live over here on the Four Corners. And that's just simply because of the direction that the air is being pulled to you. So if you're here on the Four Corners, you're getting air from the northwest, which is basically going to be drier air, and you're going to see dry conditions. If you're over here in San Francisco, even though it's a high pressure that's affecting you, your air is circulating down and around, and so it actually can be drawing air from the ocean here, and it could actually cause rain and stuff up in San Francisco. It can also cause wind conditions coming from the south, and you create a lot of havoc for San Francisco. If you once you learn about the characteristics specifically of San Francisco, you'd understand why. But yeah, yep, Santa Ana winds, yep. That's how you get them a lot when they come up from like Mexico and up into California like that. Yep, exactly. Now, if you had a low pressure system sitting over this same spot, low pressures, just remember, counterclockwise. The low pressure systems are going to be more associated, low pressure is normally associated with bad weather, okay? So if you look at anything associated with a low pressure, that's like your thunderstorms, tornadoes, all of those things are counterclockwise movement. A tornado, if you ever get to see one, it spins counterclockwise in the northern hemisphere. In the southern hemisphere, it spins clockwise. That's just simply the Coriolis effect. But if this was a low pressure sitting here over St. George, and now you think, well, where's our wind? Where's our wind coming from? Well, it's actually being drawn right from California, right off of the ocean up into St. George. that's generally going to cause rain here. If you're, and like I said, it all depends on the placement. So let's take a look here at the current pressure systems that are out there. Pressure systems. Let's see. Here we go.
So it also said that lows pull air in, highs push air out.
Exactly. Yep. So it's just the funnel effect of how it's going. So a high pressure swirls it clockwise, but it takes it and it lifts it up and goes out the top. Whereas a low pressure brings it in, it sucks it down and shoots it out the bottom. So that's kind of like what they're meaning there. Let me actually get to a better one here. So that's not even the one I wanted. I wanted this one. Okay.
There's a lot going on.
Yeah. But you can start to look here, and it might not make a lot of sense right now when you look at it, but I mean, everywhere you see a low, the air around this is going to be counterclockwise. And then you see a high here, high here. But the one thing that's important to kind of know with both highs and lows is that you're always going to have highs sitting next to lows. I mean, that's just the way it usually will work. But the reason for that is because the way the air circulates, like on this one here, the air, will be coming up underneath like this, and then it hits into this high, and then actually as it comes up in the middle here, it then gets turned this way, and then it gets around this low, and it goes back around. So it's kind of crazy. If you ever has anyone ever seen the jet stream? When you look at the jet stream going across the United States, you'll see that it kind of zigzags. Sometimes it goes in a straight line. Sometimes it all is dependent upon the placement of the high and low pressure systems, because of the jet stream, all it's doing is it's weaving its way in between high and low pressure systems. So, it might start over here and like come up underneath, and then, it might like stay underneath here, and then it might curve up over this high, and then come down here underneath this low, and then stay, and then go, around this high and down. I mean, it just depends on, where it's at, but that's all dependent like on how it actually will form the jet stream, all of these different low and high pressure systems. So the other thing here, these are frontal boundaries. Like this is a cold front. This triangular, circular blue thing, and then these red ones here are warm fronts. And then when you see it together, like you see blue, red, that's a warm and a cold front that are converged together. So sometimes they'll call them stationary fronts or occluded fronts. You'll learn more about those though. But anyway, the only thing here, like I said, the big takeaway from any of this is just knowing that high pressure, clockwise movement, air is being pushed out the top. Low pressure, counterclockwise movement, air is being sucked in and pushed out the bottom. And generally speaking, high pressure associated with better weather, low pressure associated with bad weather. Yeah.
I'm going to have a stupid question. I don't know. But so for any other area that is not a low or a high pressure, what is going on there?
Well, first of all, you always typically will have a high or a low. The only other types of pressure systems is see this line right here? That is what's called a trough. And it's just basically an area where air has kind of just settled between pressure systems. But you always have one of the types of pressure systems. And generally speaking, 95% of the time it's going to be either a high or a low. So even though it doesn't have for instance, there's this gap here, right, between
Iowa, Montana,
Okay, yeah. The only difference here is that the high pressure system, like you see HHH, it's actually encompassing this entire area. So it doesn't actually draw a boundary on it. It's just that it's a bigger high pressure system. That's all it is. So when you see them together like this is really one huge one right here. They could just put one H right here in the middle and then draw a huge line if they wanted to, but it's kind of harder to depict it that way rather than just doing like all of the little different H's everywhere. But yeah, when you see them together like this, it really just means this is more of the boundary. So if you were to just draw a line around it like that is really, so that whole area is a high pressure. So right now it should be generally good weather out that direction. But yeah, we'll look a lot more into this stuff. But like I said, for right now, the only big thing is just knowing high pressure, clockwise, low pressure, counterclockwise. High pressure is generally good weather. Low pressure is generally bad weather. So let's take a break for 10 or 15 minutes. I'm going to see if I can turn up the air. You guys ready for another video?
Ready. So ready.
Does it feel any warmer?
No.
Okay. Well, next time we will.
Bring blankets and.
Well, we'll try and go into one of these ones that has a thermostat actually in it.
A thunderstorm makes its way through 3 distinct stages before dissipating, as shown above. It begins with the cumulus stage, in which lifting action of the air begins. If sufficient moisture and instability are present, the clouds continue to increase in vertical height. Continuous, strong updrafts prohibit moisture from falling. The updraft region grows larger than the individual thermals feeding the storm. Within approximately 15 minutes, the thunderstorm reaches the mature stage, which is the most violent time period of the thunderstorm's life cycle. At this point, drops of moisture, whether rain or ice, are too heavy for the cloud to support and begin falling in the form of rain or hail. This creates a downward motion of the air. Warm, rising air, cool, precipitation-induced descending air, and violent turbulence all exist within and near the cloud. Below the cloud, the downrushing air increases surface winds and decreases the temperature. Once the vertical motion near the top of the cloud slows down, the top of the cloud spreads out and takes on an anvil-like shape. At this point, the storm enters the dissipating stage. This is when the downdrafts spread out and replace the updrafts needed to sustain the storm. It is impossible to fly over thunderstorms in light aircraft. Severe thunderstorms can punch through the tropopause and reach staggering heights of 50,000 to 60,000 feet, depending on latitude. Flying under thunderstorms can subject aircraft to rain, hail, damaging lightning, and violent turbulence. A good rule of thumb is to circumnavigate thunderstorms identified as severe or giving an intense radar echo by at least 20 nautical miles (nm), since hail may fall from miles outside the clouds. If flying around the thunderstorm is not an option, stay on the ground until it passes. For aviation purposes, a ceiling is the lowest layer of clouds reported as being broken or overcast, or the vertical visibility into an obscuration like fog or haze. Clouds are reported as broken when 5/8 to 7/8 of the sky is covered with clouds. Overcast means the entire sky is covered with clouds. Current ceiling information is reported by the Aviation Routine Weather Report, METAR, and automated weather stations of various types. Closely related to cloud cover and reported ceilings is visibility information. Visibility refers to the greatest horizontal distance at which prominent objects can be viewed with the naked eye. Current visibility is also reported in METAR and other aviation weather reports, as well as by automated weather systems. Visibility information, as predicted by meteorologists, is available for a pilot during a pre-flight weather briefing. Precipitation refers to any type of water particles that form in the atmosphere and fall to the ground. It has a profound impact on flight safety. Depending on the form of precipitation, it can reduce visibility, create icing situations, and affect landing and takeoff performance of an aircraft. Precipitation occurs because water or ice particles in clouds grow in size until the atmosphere can no longer support them. It can occur in several forms as it falls toward the earth, including drizzle, rain, ice pellets, hail, snow, and ice. Precipitation in any form poses a threat to safety of flight. Often, precipitation is accompanied by low ceilings and reduced visibility. Aircraft that have ice, snow, or frost on their surfaces must be carefully cleaned prior to beginning a flight because of the possible airflow disruption and loss of lift. Rain can contribute to water in the fuel tanks. Precipitation can create hazards on the runway surface itself, making takeoffs and landings difficult, if not impossible, due to snow, ice, or pooling water and very slick surfaces. Air masses are classified according to the regions where they originate. They are large bodies of air that take on the characteristics of the surrounding area, or source region. A source region is typically an area in which the air remains relatively stagnant for a period of days or longer. During this time of stagnation, the air mass takes on the temperature and moisture characteristics of the source region. Areas of stagnation can be found in the polar regions, tropical oceans, and dry deserts. Air masses are generally identified as polar or tropical, depending on the temperature characteristics, and maritime or continental, based on moisture content. As shown above, a continental polar air mass forms over a polar region and brings cool, dry air with it. Maritime tropical air masses form over warm tropical waters like the Caribbean Sea and bring warm, moist air. As an air mass moves across bodies of water and land, it eventually comes in contact with another air mass with different characteristics. The boundary layer between two types of air masses is known as a front. An approaching front of any type always means changes to the weather are imminent. Shown above are the four types of fronts, which are named according to the temperature of the advancing air relative to the temperature of the air it is replacing: warm, cold, stationary, occluded. A warm front occurs when a warm mass of air advances and replaces a body of colder air. Warm fronts move slowly, typically 10 to 25 miles per hour mph. The slope of the advancing front slides over the top of the cooler air and gradually pushes it out of the area. Warm fronts contain warm air that often have very high humidity. As the warm air is lifted, the temperature drops and condensation occurs. The picture above depicts a warm front advancing eastward from St. Louis, Missouri, toward Pittsburgh, Pennsylvania. At the time of departure from Pittsburgh, the weather is good VFR, with a scattered layer of cirrus clouds at 15,000 feet. As the flight progresses westward to Columbus and closer to the oncoming warm front, the clouds deepen and become increasingly stratiform in appearance, with a ceiling of 6,000 feet. The visibility decreases to 6 miles in haze, with a falling barometric pressure. Approaching Indianapolis, the weather deteriorates to broken clouds at 2,000 feet, with 3 miles visibility and rain. With the temperature and dew point the same, fog is likely. At St. Louis, the sky is overcast with low clouds and drizzle, and the visibility is 1 mile. Beyond Indianapolis, the ceiling and visibility would be too low to continue VFR. Therefore, it would be wise to remain in Indianapolis until the warm front had passed, which might require a day or two. A cold front occurs when a mass of cold, dense, and stable air advances and replaces a body of warmer air. Cold fronts move more rapidly than warm fronts, progressing at a rate of 25 to 30 miles an hour. However, extreme cold fronts have been recorded moving at speeds of up to 60 miles per hour. A typical cold front moves in a manner opposite that of a warm front. It is so dense it stays close to the ground and acts like a snowplow, sliding under the warm air and forcing the less dense air aloft. The rapidly ascending air causes the temperature to decrease suddenly, forcing the creation of clouds. The type of clouds that form depends on the stability of the warmer air mass. A cold front in the northern hemisphere is normally oriented in a northeast to southwest manner and can be several hundred miles long, encompassing a large area of land. Fast-moving cold fronts are pushed by intense pressure systems far behind the actual front. The friction between the ground and the cold front retards the movement of the front and creates a steeper frontal surface. This results in a very narrow band of weather, concentrated along the leading edge of the front. A continuous line of thunderstorms, or squall line, may form along or ahead of the front. Squall lines present a serious hazard to pilots, as squall-type thunderstorms are intense and move quickly. The above picture shows a flight from Pittsburgh, Pennsylvania, toward St. Louis, Missouri. At the time of departure from Pittsburgh, the weather is VFR, with 3 miles visibility in smoke and a scattered layer of clouds at 3,500 feet. As the flight progresses westward to Columbus and closer to the oncoming cold front, the clouds show signs of vertical development, with a broken layer at 2,500 feet. The visibility is 6 miles in haze with a falling barometric pressure. Approaching Indianapolis, the weather has deteriorated to overcast clouds at 1,000 feet and 3 miles visibility with thunderstorms and heavy rain showers. At St. Louis, the weather gets better with scattered clouds at 1,000 feet and a 10-mile visibility. A pilot using sound judgment based on the knowledge of frontal conditions would most likely remain in Indianapolis until the front had passed. When the forces of two air masses are relatively equal, the boundary or front that separates them remains stationary and influences the local weather for days. This front is called a stationary front. The weather associated with the stationary front is typically a mixture that can be found in both warm and cold fronts. An occluded front occurs when a fast-moving cold front catches up with a slow-moving warm front. As the occluded front approaches, warm front weather prevails, but is immediately followed by cold front weather. There are 2 types of occluded fronts that can occur, and the temperatures of the colliding frontal systems play a large part in defining the type of front and the resulting weather. The above picture depicts a cross-section of a typical cold front occlusion. A cold front occlusion occurs when a fast-moving cold front is colder than the air ahead of the slow-moving warm front. When this occurs, the cold air replaces the cool air and forces the warm front aloft into the atmosphere. Typically, the cold front occlusion creates a mixture of weather found in both warm and cold fronts, providing the air is relatively stable. A warm front occlusion occurs when the air ahead of the warm front is colder than the air of the cold front. When this is the case, the cold front rides up and over the warm front. If the air forced aloft by the warm front occlusion is unstable, the weather is more severe than the weather found in a cold front occlusion. Embedded thunderstorms, rain, and fog are likely to occur. Weather can pose serious hazards to flight, and a thunderstorm packs just about every weather hazard known to aviation into one vicious bundle. These hazards occur individually or in combinations, and most can be found in a squall line. For a thunderstorm to form, the air must have sufficient water vapor, an unstable lapse rate, and an initial lifting action to start the storm process. Fronts, converging winds, and troughs aloft force upward motion spawning these storms. which often form into squall lines. A squall line is a narrow band of active thunderstorms. Often it develops on or ahead of a cold front in moist, unstable air, but it may develop in unstable air far removed from any front. The line may be too long to detour easily, and too wide and severe to penetrate. It often contains steady-state thunderstorms and presents the single most intense weather hazard to aircraft. It usually forms rapidly, generally reaching maximum intensity during the late afternoon and the first few hours of darkness. The most violent thunderstorms draw air into their cloud bases with great vigor. If the incoming air has any initial rotating motion, it often forms an extremely concentrated vortex from the surface well into the cloud. Meteorologists have estimated that wind in such a vortex can exceed 200 knots. If the cloud does not reach the surface, it is a funnel cloud. If it touches a land surface, it is a tornado. An aircraft entering a tornado vortex is almost certain to suffer structural damage. Since the vortex extends well into the cloud, any pilot inadvertently caught on instruments in a severe thunderstorm could encounter a hidden vortex. Potentially hazardous turbulence is present in all thunderstorms, and a severe thunderstorm can destroy an aircraft. Strongest turbulence within the cloud occurs with shear between updrafts and downdrafts. Outside the cloud, shear turbulence has been encountered several thousand feet above and 20 miles laterally from a severe storm. Updrafts in a thunderstorm support abundant liquid water with relatively large droplet sizes. When carried above the freezing level, the water becomes supercooled. Supercooled water freezes on impact with an aircraft. Clear icing can occur at any altitude above the freezing level, but at high levels, icing from smaller droplets may be rime, or mixed rime and clear ice. Thunderstorms are not the only area where pilots could encounter icing conditions. Pilots should be alert for icing anytime the temperature approaches 0 degrees Celsius and visible moisture is present. Hail competes with turbulence as the greatest thunderstorm hazard to aircraft. Supercooled drops above the freezing level begin to freeze. Once a drop has frozen, other drops latch on and freeze to it, so the hailstone grows, sometimes into a huge ice ball. Eventually, the hailstones fall, possibly some distance from the storm core. Hail may be encountered in clear air several miles from thunderstorm clouds. As hailstones fall through air whose temperature is above 0 degrees Celsius, they begin to melt, and precipitation may reach the ground as either hail or rain. Rain at the surface does not mean the absence of hail aloft. Possible hail should be anticipated with any thunderstorm, especially beneath the anvil of a large cumulonimbus. Hailstones larger than 1/2 inch in diameter can significantly damage an aircraft in a few seconds. Generally, visibility is near zero within a thunderstorm cloud. Ceiling and visibility also may be restricted in precipitation and dust between the cloud base and the ground. Pressure usually falls rapidly with the approach of a thunderstorm, rises sharply with the onset of the first gust and arrival of the cold downdraft and heavy rain showers, and then falls back to normal as the storm moves on. This cycle of pressure change may occur in 15 minutes. If the pilot does not receive a corrected altimeter setting, the altimeter may be more than 100 feet in error. A lightning strike can puncture the skin of an aircraft and damage communications and electronic navigational equipment. Although lightning has been suspected of igniting fuel vapors and causing an explosion, serious accidents due to lightning strikes are rare. Nearby lightning can blind the pilot, rendering him or her momentarily unable to navigate either by instrument or visual reference. Nearby lightning can also induce permanent errors in the magnetic compass. Lightning discharges, even distant ones, can disrupt radio communications on low and medium frequencies. Turbine engines have a limit on the amount of water they can ingest. Updrafts are present in many thunderstorms, particularly those in the developing stages. If the updraft velocity in the thunderstorm approaches or exceeds the terminal velocity of the falling raindrops, very high concentrations of water may occur. It is possible that these concentrations can be in excess of the quantity of water turbine engines are designed to ingest. Therefore, severe thunderstorms may contain areas of high water concentration, which could result in flameout and/or structural failure of one or more engines. We hope you learned a lot. Please help us spread the word about Pilot Training System, and we look forward to further servicing your flight training needs.
Oops, not replay. Moral of the story: don't fly into thunderstorms.
That's what it does.
Yes. The big thing there is, and you'll see in, when you actually dispatch as well, is you typically want to avoid thunderstorms pretty much at all costs. Sometimes it's unavoidable and you have to fly in and around them. But the big thing is and it kind of touched on a little bit, of those big squall line, they call them squall line thunderstorms. Those are the big ones that I was talking about earlier, that they usually are along or in front of a cold front. As a cold front moves across the country, you can see like an entire huge line of thunderstorms, and sometimes you can't fly through it or penetrate through it, and you got to route around it. Those are the tougher ones to deal with just because of how much you got to move around them. But the other type, so there's that type of thunderstorm, and then the other type of thunderstorm are the air mass thunderstorms, which is typically more like we see here. We don't see squall line thunderstorms really out in the mountain area. Anywhere really west of Denver, you don't see squall line thunderstorms at all. That's primarily all going to be Midwest and further going out into the east. So we don't normally see it here much, but we see what's just called the air mass thunderstorms, where you get just individual little thunderstorm cells that will pop up and just form. You'll get one over here, one over there, but it's really just more, they don't necessarily form together, and it's not due to a cold front. It's just simply due to having moist air, the convection lifting process, where the Earth's surface is heating up, and then lifting that air, that moist air, up into the atmosphere, and then it cools, and then it forms a thunderstorm. Those are just localized thunderstorms, though, that actually build and mature and dissipate all, potentially within 15 to 30 minutes, and it could do all of that and be done, and then it's gone. So quite a bit different than the squall line type thunderstorm, but nonetheless, both of them have the same characteristics, and both of them pose the same amount of hazard. So when you're routing aircraft and designing your route and everything that you're going to have your flights fly, you always want to try and avoid thunderstorms. The one thing that's tough with a squall line thunderstorm, it's a little bit easier because you can normally see it, and it normally lasts all day long, and you can see it moving across, and it'll last for hours and hours, and you just see the whole thing move across an entire state. The ones that are hard to predict are going to be the air mass thunderstorms, where they pop up, mature, and dissipate, like I said, all within 30 minutes time. Those ones you can't ever see ahead of time. You can't predict them ahead of time. And at the time that you're actually preparing your flight release, in some cases it's always going to be at least 90 minutes to 2 hours before the flight even takes off. And depending on, where it's going, it could be as much as 4 or 5 hours before it reaches its destination. So a lot of times you're looking 4 or 5 hours ahead of time. You're trying to figure out, well, what's going to happen, at my destination. Like Denver, like I said, in the last time we met, is a hard one to predict because they are notorious for getting those afternoon pop-up thunderstorms, not the squall line type, but the air mass type of thunderstorms. And you have to just kind of plan for it, just assuming that it's going to happen, even though it might just be a 50-50 chance. You're really just guessing a lot of the time. But you usually end up just planning stuff, just kind of, better to be safe than sorry. If they end up getting to their destination and you have a pop-up thunderstorm, like I was saying earlier, one of those little pop-up thunderstorms for 30 minutes, if it's in the vicinity of the airport, can cause mass amounts of diversions depending on the timing of it. So you don't want to be caught up in one of those, not necessarily in the thunderstorm, but they end up putting all of the aircraft into holds because they can't land them because there's a thunderstorm and they're potentially going to, have to deal with a lot of those hazards, hail, the downdrafts, lightning. So all of that stuff, obviously, thunderstorms are the biggest weather problem for aviation. So that's you're always going to want to try and avoid them as much as possible and fuel your flights so that they can hold for, just hold in an area of good weather while a thunderstorm clears out of the area that they're trying to go to. Or route around, if you know that you're going to have an area of potential pop-up thunderstorms or a squall line thunderstorm area. So those are the big things to take away from that. As far as all those characteristics that you learned about, I know it kind of just throws a lot of information at you, just like every other one of our things that we've been looking at. But really just take away from it, you knock it down to just caveman style, just thunderstorms bad,
So, I have a question about, this is like going back, I just was thinking about it, when we have a diversion, after they land at their alternate airport, what happens then with like the passengers and the plane? Like, do we have to plan them to come back or?
Typically, yes. That there's a lot of things that can happen, but the ultimate the what you're trying to do, as long as there's several things that kind of have to obviously align. But let's say it's a situation where you had a thunderstorm pop up over Denver or whatever, or any airport. Typically, that's just going to be a momentary thing, right? So you divert to an alternate airport, you land. Normally, just the ideal situation is you land, you get gas. Normally, don't even deplane.
Oh, okay.
And then fuel back up. The dispatcher sends, if you divert, the dispatcher does have to then prepare another flight release where it's from the diversion airport to what the destination was supposed to be. And then they plan the route. They do all the normal stuff that they did on the original dispatch release, and they file the flight plan, send the release. They can normally do all of that pretty quick, though. And then in a lot of cases, sometimes they have all of that ready to go before the flight even lands at the alternate. And so sometimes even on that ACAR system, they'll say, hey, I've already got your release ready to go. Your fuel, once you land, you're going to want to put on 6,000 pounds of fuel, and we should be good to go. The only things that affect that, though, that's what should always happen, and ideally that's normally what does happen. The only things that affect that, though, are going to be like if you're in an area, like going back to the Denver situation, if you have 70 diversions, a lot of times those alternate airports are going to be just totally inundated with diverted flights. And so sometimes you land and you got 20 people that are already there that beat you there. They're all waiting for gas, and it's some podunk airport that doesn't have normal service, and you're just completely inundating them. Like you couldn't deplane if you wanted to, because there's not even a place to park. There's the fueler guy is going one by one fueling everybody. Sometimes it takes hours. And then you have the other element of the crew, their legality, because flight crews are only legal for so many flight hours a day. They've got two different things that they track. Their overall flight duty period, which is from the time they start their day, even if they're not flying, the time that they basically check in to the airport, and they've got a certain amount of time that they have to be done by a certain time in the day. Like even if they did zero flying at all, if they checked in and let's say their flight canceled, or let's say it's on maintenance, they've kind of got a ticking clock the entire day that's like so many set hours, they got to be done. Then there's a whole other thing. And once they actually do fly, how many hours they actually log flying a plane is also tracked, and they only have a certain amount of those as well. So you can hit either one of those limits depending on how long they've been either sitting around or how much they've actually been flying. So if you divert to an airport, due to weather or whatever, you're adding on to that time. And so nowadays, like in the airline industry, especially in the regional airline industry, pilots are a lot of times scheduled already. Their schedule for the day is already nearing the absolute peak that they can normally handle. Pilots can fly, depending on what time of the day they start flying, either 8 or 9 hours of what's called block time. And so a lot of times they start their day without any interruption at all. They're already scheduled for 7, sometimes. I don't know how bad it is nowadays, but there's times where it's really bad.
In the summer, it gets.
In the summer, yeah.
It's 7.5, 7. I don't know.
Yeah, and so you think like a 30-minute diversion might put them over the 8, or it might. Then they time out. So if they time out, then they have to get they have to get on our clocks, the way like when we look at it, they need basically 10 hours of rest is what we look at it on when we schedule. But if they time out, then they would need 10 hours of rest. There's other ways around that now, depending on where they diverted, if there's another crew there, or if we could send a crew in to replace them. There's a lot of things that we can look at. But if they're somewhere where we can't get another crew in, or we can't, save the flight other than using the original crew that's now timed out, then most of the time we just have to just put everybody up in a hotel, including the crew, and go in 10 or 11 hours from that point.
New York, come back to Ireland.
Oh, really?
Yeah. The crew wasn't there and basically said, all right, well, wait.
Yeah.
Because everyone was, like you said, over there at the time, so.
Yeah. And a lot of times.
Passengers in a hotel?
Yeah. Well, it depends. Yeah, they normally will try and accommodate the passengers, but generally airlines, if it's due to weather-related stuff, there's no guarantee for the passengers. But if they're stranded, like in an outstation, like where they weren't supposed to be, the airlines usually do a pretty good job of still putting them in a hotel or at least arranging transportation. Like a lot of times, if the pilots time out, the airline will usually try to get some sort of ground transportation and bus the passengers if it's close, But there's so many different scenarios. Like yesterday, as an example, we had a plane take off from Grand Forks, North Dakota. Right after takeoff, it flew through a flock of seagulls. They hit like 20 of them. Wow. So it got
so sad.
it got pretty badly damaged from an airplane perspective. Like, even though it's damaged, it didn't have any issue flying. They immediately returned. They took off, circled around, though. They flew through the seagulls, turned around, and just landed back again at Grand Forks. So we call that an air return, like where they immediately land where they just took off from. But anyway, I believe it was the crew's first flight of the day. I'm not sure. I can't remember. But either way, they were still legal. They had still plenty of flying time left for the day. But it kind of shook the crew up a little bit mentally, emotionally speaking. And so as soon as they landed, got back on the ground, the captain called off unfit, basically. So you have all sorts of things that you deal with. The dispatcher doesn't necessarily have to deal with that stuff specifically. That's really more of like the regional controller and above that kind of deal with the problems. From a dispatcher perspective, all you care about is it going to fly or is it not going to fly? If it's not going to fly, then it's actually better for you. Work-wise, I would just as soon all my flights canceled, right? So that part of it doesn't matter for the dispatcher. It's just the people above that are actually in charge of the planes and where the crews are, and then obviously for crew support people, that's the people that have to deal with those kind of problems. But you still at least see it from the dispatch perspective. You see what happens, and you do get connected, a little bit to your flights, and you obviously want them to operate, and you care about the passengers. The dispatcher, though, the primary objective is the safety of the flight. So there's a lot of times where, from a dispatch perspective, what you end up deciding is going to be, technically, it's going to, from a business perspective, and like I said in the first class, you have those two competing things, right? You've got dispatcher who works for the airline, gets paid by the airline, but is individually licensed to make individual safety decisions that are not connected to business decisions. And it's supposed to be disconnected there, right? They're not supposed to interfere, and you're not supposed to have anybody over your shoulder saying, no, you need to get that flight to go, or to do something that would otherwise be unsafe. If the dispatcher thinks it's unsafe, then it doesn't matter. Like, the flight won't operate, which kind of brings and leads into kind of an important thing. So, and this you'll want to write down and know this. It is what we call operational control. So operational control, what it stands for is, and this part is what you want to know. Well, there's a couple of elements, but write down this part specifically. But the definition of operational control is to initiate, conduct, or terminate a flight. It's the authority, I should say, the authority to initiate, conduct, and terminate a flight.
So basically, we have the final say.
Yeah, well, there's two people that have operational control over a commercial passenger carrying flight. Those two people are the captain and the dispatcher. Those are the only two people. There is no other person that has operational control, not even the first officer. The dispatcher technically has a higher authority than even the first officer, even though he's not in the plane. The only two people that matter, decision-wise, are the captain and the dispatcher. So
That's on the ADX too.
Yeah, that would be for sure. And it'll be something you'll probably get asked in practical, and obviously it'll be on your quiz next week as well. So, but you can, a lot of people just remember that by just remembering initiate, conduct, terminate. Like if you just remember those three words, the full thing is the authority to initiate, conduct, or terminate a flight. But just initiate, conduct, terminate. Just if you can just remember it like that, then you'll always remember or be able to answer that question. So, but yeah, operational control is simply just the captain and the dispatcher. Neither one of them has more than the other. It is 50-50. If the captain doesn't want to go, it doesn't matter what the dispatcher thinks, and vice versa. If the dispatcher doesn't want to go and the captain does, it's not going to go. It's both of them have to agree, 50-50, it goes. All of the decisions for the flight are made conjointly between the dispatcher and the captain. So, outside of that, though, and the reason why that is done like that is because it's trying to avoid the business influence. Obviously airlines need to make money. Everybody gets that, and that makes sense. However, when it comes to the safety of flight, a lot of times those safety decisions are not good business decisions, if that makes sense. Obviously canceling a flight is not ever going to be a good business decision, but a lot of times it happens. And from the business perspective, those things are just completely out of the hands, and they cannot interfere with safety. So just remember that when you're actually working as a dispatcher, you do, when able, a dispatcher should be business conscious, and make good, sound decisions that obviously help the company be profitable, as long as everything else is is aligned. Like safety first, obviously, and then if you can accommodate whatever the business is trying to influence, then you do that as well. But if ever that business influence compromises safety, that's where the dispatcher has to basically draw the line, and that's where you're separated. That's where the airline has zero say. You couldn't have a manager or anybody come in and behind you and say they want you to do something. Like, they cannot interfere with anything related to the safety of the flight. So that is your own baby, if you think of it that way. Like, if a plane had an incident or if a plane crashed, obviously never would hope any of that happening, but the FAA does not go and look. The first thing they look at is the captain and the dispatcher. That's going to be the first. That is going to be where the responsibility lies. It's not going to be the airline. Now, obviously, ultimately, it can be the airline if it was deemed to have some sort of a maintenance issue, or if it's a practice that the airline teaches, But there's several different things inside of the airline where it's like this. The dispatcher obviously is one of them, where they cannot be interfered with. Maintenance personnel, anybody who is licensed by the FAA and holds an individual FAA certificated license is protected from the business influence, if that makes sense. Their decisions are not to be influenced by the business side. That's kind of all it really means. So it rarely does it ever get, where that even needs to be exercised, or need to even be brought up, because the airline pretty much always operates in accordance with what it already knows are the safety protocols. And a lot of the procedures and things it sets up are, obviously those specific safety protocols to begin with. So it's never usually a problem. It's just when it comes down to, there's a lot of little things, and I'm sure John's probably seen some of them. Like a lot of times you'll get into situations where a pilot is very near his max duty or block time for the day, and we want him to be able to. He's got one last flight to do, okay, and he's coming into the hub. He's supposed to go Salt Lake to, let's say, Billings, Montana for his last flight of the day, his overnight flight. But he maybe had a diversion earlier in the day that kind of maybe put him a little bit higher on time. Or let's say that there was some weather, he had to route around, it added to his time. And so now it's getting really close to like where he may not have enough block time left to finish that last flight. And unless we've got another captain or another crew in Salt Lake City to replace this guy with, then flight may not be able to operate. This is kind of where you start to see some of like the business influence. Not that it's really even, it's still pretty black and white. If he's over, he cannot go, and if he's under, he can go. So it basically comes down to that. But we start like kind of looking into all of his flights for the day and seeing if there was, any time that maybe got it added time where it really wasn't supposed to. And there's just a lot of little gimmicky things that we can look at and shave time off of. And so a lot of times the pilots feel like we're going in and taking off time that we're not supposed to be. And I'm sure you could probably have had those phone calls.
It looks shady when you find non-movement. Yeah,
it does. It looks shady, but and you'd have to understand the full scale of it. But it's just kind of, you get into those situations. But either way, but it's still black and white. And
do they get in pretty big trouble if they go over?
The pilots don't really. I mean, and the only situations where they ever really go over is when it's an unplanned event. Now, the thing is if an unplanned event happens early in the day, then you're gonna be able to foresee this. And like in this situation that I'm trying to describe, like if it happened earlier in the day, then you can already tell that he might not be legal to fly his last flight or two, right? If it happened on the last flight though, where everything was fine, and then he got to the last flight, he was still legal, still had enough time, he leaves on that last flight, but let's say that last flight then ends up having something happening to it where it diverts or it ends up taking a lot more time than it was supposed to. If he goes over on that last leg, as long as he launched within the parameters and he appeared to be legal when he left, and that's what we were planning on, and then he went over after the fact, then a lot of times that's just considered an uncontrolled thing, but you still have to report those and explain why it happened. But even though there wouldn't be necessarily any ramifications from it, it's where it's going to happen and you can see and you still launch even though he was going to go over. where you come into the
Does that
problems.
fall back on the dispatcher?
Not the dispatcher. No, not in that case. Pilots are responsible for their individual time tracking as well as the company.
Yeah.
So the FAA in that situation would actually go, they would wait for the company to first of all self-disclose it, and then they would review it and decide if there's any fines or whatever, basically. But if you do it enough times, they're going to come in and they're going to make you change the way you do things. So it doesn't happen enough, you know. The only time it ever happens is the most amount of times is when it happens is somebody goes into like say Chicago, and when there's a thunderstorm occurring in the area, and if it goes over the field, a lot of times planes will land, and due to the congestion at an airport, because they can't take off, it's just too crowded. There's nowhere to go. There's all these planes sitting at the gates that were supposed to have left, but they didn't leave because of the weather. And then you got ones that are still have landed and don't have a gate to go to because there's a plane sitting at the gate. So they end up sitting out on the taxiways and in these holding pads for hours, sometimes hours. We've seen them out there for 4 and 5 hours before.
They go over.
That's when they will go over, because all of that time, as long as he's in the plane with passengers, all of that time is considered block.
Yeah.
So, yeah.
Is there a limited amount of time that we can keep passengers on a plane?
There is.
Something that happened recently where we had some people that got stuck for hours.
Yeah. They call it the Passenger Bill of Rights, and it's a 3-hour rule. So from the time you leave the gate, and you know they push back the plane from the gate, you basically have 3 hours from that point to take off. And so it's kind of the same thing. If it's a circumstance which can be controlled by the airline, then if they haven't taken off by the 3-hour point, then they need to return to the gate and offer the passengers egress to get off the plane if they want to. All they have to do though is be headed back to the gate at the 3-hour point. That's kind of the 3 hours is the big thing. But when we watch it, we start sending people back to the gate around like 2.5 hours, 30 minutes to spare, so that we can not exceed the 3 hours, because that's when you can start getting into fines and stuff. Now, if it's something that's not controllable, like let's say you're in a takeoff line. Now you got to remember, planes, they can't just throw it in reverse and shimmy their way out of a takeoff line, like parallel parking. They if they can't go forward, then they can't move. That's basically, even if you have nobody behind you, if there's somebody in front of you, you can't move. So they can't back up. So if you're not in a position, like if you get on those taxiways where it's a huge long line of people waiting to take off, once you get in that line, you're in that line. Like you're not going to get out of that line unless you get to a point where there's a break off taxiway off where you could turn off and go back around. But a lot of times you're just stuck where you're at. So if it's uncontrollable, then usually it doesn't affect us. But still,
Does that happen often?
it happens a lot. Yeah, a lot. Yeah, there's all the time. You'll see fines that go out to airlines. Like the fine is if you exceed 3 hours in a controllable situation, then the fine per passenger is in the hundreds of thousands of dollars.
Per
So,
passenger?
per passenger, yeah.
Wow.
And none of that money goes to the passenger.
Oh, bummer.
But yeah, you'll see like little news articles where Southwest Airlines was fined $4 million for a DOT like bill of like a ground. They call it a ground tarmac delay. Like for tarmac delay fines for one single day, because they had 3 or 4 planes that went over 3 hours, and all of them, get fined. They end up deciding, usually lowering the fine, but
Where did the fines go if not to the passenger?
they pay those FAA guys.
It's probably nothing to Southwest though. I mean,
So,
4 million.
It's not. Yeah, it's happened to us. We've had once couple of $1 million on SkyWest too.
in what conditions, would you not be able to avoid it? So, like you're saying, it's not uncontrollable, it's controllable that you could be fined for. But when would you not take off or get back to the gate in 3 hours?
Most of it is just weather related, like where they get a bunch of people out into the takeoff line and then a thunderstorm or something comes over the field and they have to halt departures. And now everybody's just stuck in that line. And so unless the thunderstorm moves off, but you get a lot of situations where you get a thunderstorm and then you get one coming in right behind it. Like Chicago is probably the worst one for this specific type of situation. But you just get thunderstorm cell after thunderstorm cell like coming through and with nobody being able to move. But then you just get into a situation of gridlock where you've got a bunch of planes that have landed and they start parking them out on the taxiways. So like they have to get 20 planes to move just for one guy who's near the 3 hours to try to get out, and it just doesn't happen. Like that's how it happens. The only way that they ever get into a situation where they deem it as the airline's fault is basically where they were at the 2 hour mark. They knew that it was potentially going to happen and they had opportunities to return to the gate. If they're just flat out stuck, then they're stuck, but they have to be able to document that they're stuck. But if there's a situation where you get into that, it's the same thing. You get back into that business influence. Like, I don't know, I think that another 20 minutes, I think that they'll be able to take off. But you kind of get that thing like, okay, we can go 5 more minutes. We can go 20 more minutes. But then you get to that point and then you are stuck, or if you had a chance to go back, then and you don't take it, and then you go over. That's the situation. That's the other time too. Is the other big ones is just when passengers throw a fit. So they're the ones that actually end up filing the claims on it. But I didn't want to get off on too much of a tangent on passenger bill of rights.
As a dispatcher, though, you'd have to reissue that. The pipeline, right? If they got stuck, 'cause isn't it like 30 minutes?
It depends on the airport. Most of the flight plans stay filed for 4 or 5 hours, though. But from a dispatch release perspective, though, if they in a situation where if they returned to the gate, depending on how long ago the original dispatch release was issued, you may have to do another one. It's not always, but it just depends. It just depends on the situation. If it's been 2 or 3 hours, then you probably would have to. But from the point that you mark on the release, like the time that is supposed to be their departure time, the release is good for 2 hours. So if they haven't, and all that means is that the flight needs to leave the gate within 2 hours of that time. If it goes over that time, then they would need a new release. But as long as they're out of the gate, and then they're fine. You don't have to reissue it. But if they were to go out of the gate and then return to the gate, then you would need another one. So there's a whole set of criteria. But flights are tracked, though, and this is also something you're going to want to write down and know. But flights are tracked based on 4 different times. They call them OOI times. OOOI is what that's why they say OOI. But anyway, it's your out time, which just means that's the time that the door closes and the captain releases the brake, and then they push the aircraft back. That's what's called your out time. That's the time that is connected to on time performance, where if a flight says it's supposed to leave at 8:35, if it doesn't register an out time by 8:35, then the flight is not considered on time. So when you look at those that work at SkyWest, when you look at all of our little airline metric things where you have on-time performance, arrival performance, departure performance, all of those things are tracked off of these 4 times. So that's the out time, is when it leaves the gate. The next time is your off time. And the off time is just simply when it takes off, when wheels leave the ground. Then the next time is your on time, which is once your wheels touch the ground, that registers an on time. And then at the point where they open the door and release the brake or set the brake, that's your in time. So those 4 times, out, off, on, and in, are really how a flight is ultimately tracked. That's how pilots are paid and everything else.
In time with arriving at gate, setting brake.
Open door, set brake, or set brake, open door. Yeah. So you can always tell where an aircraft is. If it just has an out time, but it doesn't have an off time, you know that it's taxiing out to the runway or somewhere out there, waiting to take off. If it's out and off, then you know it's flying, but not, out and off, but not on. You know that it's in the air. And then obviously if it's on, but not in, you know it's taxiing in. And then when you see the in time, you know the flight is complete. So, I'm gonna go see if I can turn this air back off again. Because this is the first time it's turned back on since, right?
Yeah.
Give your car a look.
Yeah, I don't know which one. I know that a lot of times, even when you put it back up, they auto reset because of the programming, like in the main thing
No one
downstairs.
overrides for a little while or something.
Yeah, exactly.
Good for a second.
Yeah.
It was doing all
Yeah,
right.
it was.
Yeah, it was only a lock bolt. Super close.
So I was gonna ask on the, like you were saying, like the business versus, your own, trying to keep everything safe. So I don't know if this is how it is in dispatch, but the bonuses, how you guys get bonuses for performance and being on time, and does that affect dispatch too?
Yeah.
That could kind of persuade your decision,
It can.
It's not really that big.
It's not a big enough.
It's you don't know decision, you have to that person.
Yeah.
It's even
pretty
that,
small
like
as far as-
between every passenger.
Well, the actual performance bonus is pretty small. Yeah. So there's at ours we have. If you've been there for 1 year, then you're eligible for the performance bonuses. If you've been there for 2 years, then you're eligible for the financial and the performance combined. The financial one is the bigger one.
Right.
Obviously, still all of those metrics still hurt the financial because a lot of the bonuses from the airline, from the mainline partner that they pay SkyWest contractually is tied to their on-time performance. And so, yeah, I mean, it still is, but it doesn't make, it's never thought about, put it that way, from a dispatch perspective. Was it down again?
It was, I set it at 75 to 1,500.
Okay, good.
Yeah, it was like 69 degrees they got that program for it.
Yeah, so it's just resetting then, huh?
Yeah, it just timed out.
Yeah, okay.
Thanks for Jason.
So last thing we wanted to look at here.
Only for a few more
Because
months.
we're in a refrigerator.
Yes. Don't tell anybody.
We're gonna watch. Does anybody need to take a break again? Before you guys want, you can take another break, and then we can throw on this last video here.
I wouldn't mind that.
Okay. Yeah.
Wait for the room to.
I'll see that.
It really usually goes off without a hitch. Honestly, let me.
You guys have one recently that the nose gear didn't, or it collapsed when they landed, so they kind of just skid in on the nose. See what I'm saying?
That sounds familiar.
I don't think it was SkyWest.
It might not have been, yeah, maybe it wasn't one of your guys' flights, but.
Let's see if I can. Within 15 minutes of it happening, it was on. Yeah, it was online, right here.
So what happens as a dispatcher when you have like 3 different emergencies going on at once or whatever? It's just crazy.
Onto a scary landing at LA.
You normally don't ever have. I mean, it's rare to, from a dispatch point of view, it's rare to ever. I mean, you'll have emergencies, but you'd never. It's rare to have more than one going on, and even you only have one, maybe, I don't know, every couple of months even. So it's really not that common to have one that's from a dispatcher because there's just so many, just the odds of having it. But from the airline as a whole, it's common, so unless you're just got bad karma dispatcher. Anyway, yeah, this video, there was a helicopter that was, I guess it just hangs out right by LAX all the time. And yeah, it just records planes. Anyway. But yeah, this was the video from it, just to show you real
Onto a
quick.
scary landing at LAX when a commuter jet's landing gear failed to fully extend. KCOM9's Jeff Nguyen shows us what happened and has reaction from passengers.
A dramatic scene at LAX this morning. United Express Flight 5316 had to make an emergency landing when one of its landing gear failed to fully extend. You can see a trail of dust streaking across the runway as the left wing scraped the ground, and then sparks shooting from the tip of the wing. Here's the transmission between the pilot and the control tower.
Tower 5316, ready to 180. Is it your left gear or right gear?
180 to be the left main.
The flight operated by SkyWest had taken off from Monterey. Passengers say the pilot had to circle the airport twice.
They flew by the tower, make sure the wheels were up and down, and then they were just going to go over the ocean and dump the fuel and make the next passing come in.
From above, you can see the passengers calmly walked out as the plane came to a stop. This is cell phone video from a passenger after he was safely on the runway. You can hear the firefighters praising the crew.
Actually, this is what was amazing about the pilot was it was an incredibly smooth landing. I would say it was actually smoother than some of the landings that I've had with all of the landing gear.
6 flights were canceled, delayed, or diverted because of the emergency landing today. The airplane has been moved into a hangar at the airport where it will be inspected by the National Transportation Safety Board and the airline. At LAX, Jeff Nguyen, KCAL 9 News.
Up to a scary landing at LAX.
Anyway, yeah, the thing is that stuff they trained for. I mean, that you can actually see it. It maintained the center line of the runway even after it landed. So what they did was when they landed and they actually, the gear wasn't down, but you could kind of tell it was when the pilot decided to put the weight on the wing is when he actually let it down. So when he landed, they're trained to, like, if they have one of their back gear not down, they're actually trained that when they land, they can keep the tilt of the plane on the right side as they slow down, and then once until they have to put the weight on the wing, that's when they will let it dip down. So that's why you just see it like all of a sudden. So there, yeah, I mean, it's obviously made out to look like it was a way bigger deal than it really was. I mean, but at no time was it even. Yeah. Yeah, I mean, media nowadays, so it really was not much of an issue. That plane is back flying for us now, so it's not a big deal. But anyway, jumping back into, I was looking at, so most of the reading stuff, I mean, it's 20 pages, but most of the stuff is covered like in the videos. You can kind of see it's the same stuff that you've already been seeing here. The only thing that we haven't really looked at very much is the fog stuff. So, so when if you read through this, obviously we covered most of it, but just try and go back and look at the fog stuff, because we'll talk more about the fog stuff as we go along too. Just the different types of the fog and what their characteristics are. This other one, but right now I wanted to jump into the microburst stuff. Has anybody ever witnessed a microburst or been around near one? Microbursts get pretty crazy. It's obviously it's an effect from a thunderstorm, so it's thunderstorm related. But a microburst is a pretty big deal for aircraft. Obviously, there's been a few accidents caused by them. We're going to look at one in a few weeks that was one of the biggest microburst wrecks that ever happened. But anyway, let's watch the video for now. It's only 3 minutes, so.
Inside thunderstorms, there's lots of updrafts and downdrafts, and the air is moving a lot. In a downburst, it's where these thunderstorm winds at the top kind of rush out and hit the bottom of the ground and then move out, and it covers a wider area. In a microburst, it's a smaller scale feature, usually a mile or less, but being smaller, that air is really focused right down to the ground. So sometimes with the microburst, wind gusts can be as high as like an EF3 tornado, 150 miles an hour or higher. Inside of a thunderstorm, the air moves around a lot, and you have updrafts, the air being pulled into the storm, and then the downdraft, and that's the air pushing out. And when that reaches the top peak of the thunderstorm and is pushed down to the ground, as it hits the ground, the air spreads out. It usually spreads forward ahead of the thunderstorm. And when it hits the ground, it's accelerated, so it really starts to increase in speed, and you can have speeds in downbursts of 100 miles an hour or more, sometimes as strong as smaller tornadoes. When you look inside of a thunderstorm and you think about tornadoes, we're usually talking about wind shear or wind shifting around. So you have a lot of wind direction changes inside the storm, and that's what creates the spin for the tornado to come down to the ground. It's usually in a downburst or a downdraft. The wind is all coming from the same direction. So when you look at damage from a downburst, usually the trees are spread out in one direction. In a tornado, it's some type of twisting. You see the trees or any type of damage twisted around. Downbursts happen much more often than you would think. When you compare it to a tornado, it's usually 10 times the amount when you look back at storm reports for the year. So they're much more frequent. It's just they're usually not as intense as most tornadoes, but they can produce quite a bit of damage when you have 70, 80, even 100 mile an hour stronger winds bursting down to the earth. The strongest microburst on record was actually back in 1983. It was in Washington, D.C. at Andrews Air Force Base. The wind was clocked at least 130 miles an hour, but where they had the wind sensor, it wasn't in the center of the microburst from what they could tell on radar, so it may have been even stronger speeds, up to 150 miles an hour. And the interesting part with that, it wasn't that long before, several minutes before, where Air Force One actually landed there at the Air Force Base. Thankfully, it wasn't near the microburst at the time. A few minutes later, it kind of rolled through. So you can imagine what 130 to 150 mile an hour winds would have done for damage had it been in an area that was more populated.
Anyway, that was just short and sweet. But the thing about microbursts is most of the runways and stuff, most of the bigger airports have what are called wind shear microburst detection systems on the ends of the runways. And not even so much the ends. I mean, they'll have them at the ends, but they'll also extend them out to where it's several hundred feet past even where the runway begins. Like Denver, you're going to hear Denver come up a lot because Denver deals a lot with thunderstorm type stuff, microburst type stuff. So, but most airports, Salt Lake, I'm not sure Vegas, but most big airports have microburst detection systems, and it's just basically these little sensors that will sense a sudden wind shift. So if you remember looking back to I'm going to go back up to this thunderstorm stage deal here. I've already passed it. Yeah, I guess I passed it. Okay. So in a thunderstorm, you will always have, you don't necessarily get a microburst with every thunderstorm, but you do get a downdraft with every thunderstorm. And that's just simply, it's the dissipating stage of the thunderstorm. So every thunderstorm, when you look at the three stages, and also just in case I didn't say earlier, you do want to know the three stages of a thunderstorm. Cumulus, mature, dissipating. Those are your three stages. But the dissipating stage, every thunderstorm obviously has to dissipate, and the way that a thunderstorm dissipates is basically what that whole thing even stands for is it's releasing that air out of the thunderstorm, and that's basically how a thunderstorm dissipates, is the bottom basically drops out of it. It just opens up, and all of that air that was inside of the thunderstorm or above the thunderstorm, it just basically funnels that thing straight through, and you can kind of see in this diagram here, it just pushes it all straight down towards the ground. Once it hits the ground, that's where it does that rollout effect. So it hits the ground, and then it doesn't show it on here, but kind of maybe more in this one over here. But you can get it during the mature and specifically mostly during the dissipating stage. But it hits the ground, and then that wind, as it hits the ground, it's kind of like it bounces and it rolls out to the sides. That's where you get really the strongest wind. But that wind, it doesn't necessarily, it's going along the ground, but it can reach heights of several hundred feet up into the air, up 500,000 feet up. So as a plane, a downdraft or a microburst really isn't a big deal to a plane if it's at altitude. You're never really going to see them clear up at high altitude anyway, because it kind of is not where they'll ever really occur. But if you had a downdraft, and if a plane, you can imagine a plane flying into a microburst or into a downdraft, it's going to push the plane down towards the ground. If it's at a higher altitude, like I said, it doesn't matter. But the problem is that they're never really at high altitudes. They're always going to be at these lower altitudes. So they're a problem when a plane is descending or approaching the runway. If it flies through a microburst, you're already only, like I said, 500 to 1,000 feet off the ground. So depending on the strength of the microburst, if a crew doesn't recognize that they're flying into one very quickly, then that response time basically can turn deadly. Because if you don't respond quick enough and recognize what a microburst is, or what the effect it has on an airplane, then it can completely overpower an airplane and push it right down into the ground and cause it to wreck. That's the accident that we're going to look at in a couple of weeks. You'll see that's exactly what happened. But most of the airports and even the airplanes have wind shear and microburst detection systems in them now, to where if an airport detects that a microburst is going on anywhere around the airport, these sensors go off and it rings off these sirens up in the tower, the ATC tower, and they will halt all landings. They'll put everybody into a holding pattern, and they will not allow anybody to land for 20 minutes. So from the last wind shear or microburst alert, they have to wait 20 minutes before they can let anybody land. So anytime it goes off, it's like it resets the clock another 20 minutes. And so that can obviously cause a lot of diversions. And that's one of the things that, when thunderstorms are over a field, that's one of the big things that will go off, is those wind shear alerts. But a plane, so if you can think of a microburst coming down, the air hitting the ground, and then it rolls out this way and it rolls out this way. If a plane is flying into that, one of the big things that for a plane, when they're landing, you always want to land and take off into the wind. So that's what creates better performance, and we'll talk more about that when we get into performance. But when a plane flies into a microburst, the very first thing that the pilot should notice is a sudden increase in headwind. They already are flying into a headwind, or should be flying into a headwind, but it's just all of a sudden a much greater headwind all of a sudden occurs, and obviously a decrease in their speed, because it's obviously going to slow a plane down. As they fly through it, that's the first thing that should alarm them we might be flying into a microburst, is the big headwind and decrease in speed. Then the next thing would be the downdraft. They'll feel themselves going down, and then as they go through it, depending on the severity, it might already be too late at that point, by the way, but obviously there's only been one big crash ever, so they do a pretty good job of not flying into these now. So as they go underneath, and even if they make it through the microburst, once they go through it, they then, because of the clouds that are pushing out this way, you'll get then a sudden big tailwind. And a tailwind is also very bad for landing. So it increases your speed, it pushes you further, it decreases the performance of the airplane, and it'll push you further down the runway than you actually want to land. So that's how you can tell. Those are like the identifying things for a crew, for a flight crew, of how you might detect that you're going into a microburst. But obviously you want to avoid them, you want to stay out of them. They're very dangerous, very hazardous. But like I say, there's a lot of protections nowadays that don't, that crews and airports take to not have that ever happen. So any questions on microbursts?
So, wind shears, is that just like a more common name for microburst?
Yeah, they'll call it, they specifically will call it low-level wind shear. That's usually just, low-level wind shear just simply means downdrafts. But a wind shear basically means a change in wind direction, a sudden change in wind direction of more than 20 knots. So that's really what the definition of low-level wind shear is. But one of the primary causes of that would be a microburst. But it can happen due to a lot of other things. Like low-level wind shear can happen just due to terrain even, So it doesn't necessarily always mean that it's a microburst, but a microburst will be one of the biggest causes of it. So if you're in an area where it's just wide open plains, flat ground, and you have wind shear, that's typically going to be thunderstorm related or microburst related. So in Denver, it's usually that because it's far enough away from the mountains where that's not, going to be the cause of it. And if there's a thunderstorm nearby, and the problem is with microbursts is that sometimes they're visible, sometimes they're not. Has anyone ever been watching a thunderstorm and you just see a big column of what looks like just rain? You can see off in the distance that you can tell that it's raining, but usually when you see those big columns like that, that's actually usually a downdraft or a microburst. So, and like I say, every thunderstorm will have, to a certain extent, it'll always have a downdraft when it dissipates, but just depending on the strength of the thunderstorm, it might be to the severity that you could classify it as a microburst. But not all of them will get that bad, but you'll always still usually see the downdraft column, and if it has the rain in it, that's where it actually becomes visible to the eye. If it doesn't have the moisture in it, and that's the problem, is they're not usually visible. So
and that's just when the storm is like dissipating, like when it's not, there's really no downdraft.
Yeah, you can look like, even just like last week here, I don't think there's any going on today from the looks of it. It looks pretty, like when you look out over the mountains or when you look out over here, you can see those clouds just rising up like those building clouds. Yeah, you can usually tell the different stages just by watching it. And if you got time to just sit there and watch, it's kind of cool. Like how, like when you're looking at it just casually, it's like you look out and like, oh, those clouds look cool, but then you don't look at it for a few minutes and then you look back at it and then it's like even higher and then it has that anvil top. That's how you can tell like when it's like suddenly like maturing and then when it's dissipating, that's usually when you'll see those columns. But that's only if it has moisture in it though. So you have to have the moisture in it to actually have it become a thunderstorm. And a lot of times you'll see the clouds, but it won't necessarily, it'll be the exact same thing, and it'll still be the lifting action, but it'll just continue to lift and lift. And that was kind of what I was talking about earlier. Like if it's hot enough and it's still hot enough height, like if it doesn't cool enough, they won't necessarily ever reach that level of cooling that they need to actually turn into a thunderstorm. So that's why sometimes you'll see it get way cloudy, but you don't see it actually turn into a thunderstorm. So there's several ingredients that are needed. That's why it's more common to see it like over the mountains, because the mountains, that air naturally is going to be cooler, and that's why like if you look over Pine Valley Mountain, like, you'll see the clouds and stuff form more over that than it will like over town here. So let's see here. Yeah, that's pretty much it. So anybody opposed to getting out early?
Sounds great. So just the fog part?
Yeah, just the fog part, really. I mean, the air masses were covered pretty well, like from the video stuff. So you can kind of condense the reading down a little bit more to just the fog stuff and this like lake effect stuff here. Like, so it's going to be a smaller section that you really need to pay more attention to. But fog, and then maybe just look a little bit more at the types of the ice. I know it covered it briefly, but it's just a small section anyway. But just know there's three main types of ice. So there's clear, rime, and mixed. Just know what the differences between those three, and that shouldn't take
There's
very
a
long.
lot more in section for day 4 for that.
Yeah. Yep. So, cool. Any questions?
On the quiz, will you let us know, like what we're gonna be looking, or like, needing to know, or is it just basically what you've already told us?
That's just basically when I say like write it down and stuff, I'm basically telling you quiz questions.
From day 1 till, I guess, today, all that kind of stuff.
Yep. Yep.